My name is Clark Ngo, and I'm a Master of Science in Computer Science student in CityU University of Seattle. My advisors are Dr. Jin Chang and Dr. Sam Chung, and my topic is about software documentation and architectural analysis of full stack development. This is my outline, and my motivation is a lot of people have been saying go open source. It's easy to contribute, it's easy to fix bugs and add features, but again, without visual architectural modeling, it's just so hard to understand the code base. And because of that, it has a steep learning curve as well as full stack development because of the complex technology. And another motivation would be Agjani's study of 955 document issues, and 227 of them were about missing or poor documentation and missing diagrams in open source projects. And for the problem statement, so how can we reduce the steep learning curve for both open source and full stack web development? But before that, why do we need to reduce the steep learning curve? It's because if we reduce that learning curve, the return on investment would now be increased for the software development, as it will lead to faster building of new features and fixing or bugs, right? Background learning curve is basically the representation of how fast a person would gain the experience or skill, with the right hand side image showing it needs more time to gain knowledge. And for documentation, it's analogous to having a website homepage. It should be intuitive, easy to read, and very attractive, as well as the open source readme.md, and basically it's a markdown file. And for the architectural analysis, we'll be using architectural modeling in UML. And for the full stack development, we're using MeanStack with MongoDB as a database, Express as the backend framework, Angular as a front-end framework, and Node.js as the backend runtime environment. And for the previous work, it already shows that adding architectural modeling to text-based documentation increases the understanding of new users for the functionality of the software. And for the previous work, the key papers doesn't completely hit all the keywords that we have in our research. 4+1 view model with the logical view, development view, physical view, process view, and scenarios that have different users that needs them. And for my approach, I basically would hit all the keywords that I mentioned in my research. And for the implementation, using the 4+1 view, design view and experiment validation, and color-coded diagrams. The highlight for this one is using Lucidchart for my architecture modeler to create those diagrams. And for my scenario, using sequence diagram, it shows you there's a user that hits a URL, and now that URL would now be reach the front end with the router, and now that router would call a component called books component, and the component would call the service to retrieve data. The service fetch books would now be the one communicating to the backend and make that request, and now the backend also has a router, a controller, a model would now query the database, and the database would process that, and now the backend waiting for that data now fulfills that callback from both the model and controller, and the controller can now send back a JSON response and give that back to the front end, and now generate an object, and now with that object generate a data plus template view to the user. And now for the evaluation, we have participants answering the survey for official documentation, and a different set of participants for survey for others documentation. And we do ask them their level of knowledge for all the keywords that we have for the research, and also check the increase of level of understanding, and also which part of the documentation was helpful, the diagrams, the description, the overall rating, and any suggestions and feedback. And again, it might have potential bias just being a research group, and also has a small sample size. For the results and finding, you can always see that the right hand side has higher scores, and it basically says that the author's documentation is 13% better than the other documentation. And for the future work, we can add PWA, which is the Progress Web Application for the offline capabilities. And it shows you by adding in the middle with the web storage, we have the cache, and it returns data with both the offline and online connectivity. And as for the conclusion, we can just say that the author's documentation is 13% more better and effective than the official documentation, thus reducing the learning curve. And these are my references. And if you have any questions, comment down the video below, ask me on LinkedIn, and my GitHub is where my documentation is. Thank you.